Okay, so if you're doing A-level physics, you probably know that most of the calculations involve very, very small quantities or very, very large quantities, which when most of you are punching into the calculator, you get it wrong, which is resulting in a wrong answer. But concept on what is here. So in this tutorial, I'm going to show you how to avoid those silly mistakes. So the purpose of this tutorial is to show you how you use your calculator effectively so that you can avoid those silly errors. Okay, so what we are going to do is that we're going to solve this physics problem and to the point where we must apply the calculator. Then I'll show you the trick.
Okay, brief announcement. So me and the team of teachers behind me, we want to help you get better, be it with your mathematics. Maybe you want to get better with physics. We want to help you, but the only favor we require from you is just that little subscribe click, that 2-second click. So with that being said, let's get back into the video.
Okay, so this is a simple problem which is saying that two electrons separated by a distance of 3.2 times 10 to the power negative 12 meters, assuming E naught permittivity of free space is equal to 8.85 times 10 to the power negative 12, and also assuming that the charge of an electron is equal to 1.6 times 10 to the power negative 19 coulombs. Okay, so the question is saying now that calculate the force between the electrons, right? Okay, so to calculate the electric force between the electrons, we know that we use this formula, which says that F, the electric force, is equal to Q1, which is the first electron, times Q2, which is the second electron, over R squared, R being the distance between the electrons, times K, which is the constant, right? So therefore, so we know that the constant K is equal to 1 over 4 pi E naught, right? Epsilon naught. So therefore, we can further write this formula like this. So therefore, the force between the electrons is equal to Q1, Q2 over R squared 4 pi E naught, right? So therefore, what's left is for us to just substitute the variables with their values, right? Okay, so we are now substituting the variables with the values now. So we know that Q1 is standing for the first electron and Q2 is standing for the second electron, of which the charge on an electron is just the same. So therefore, Q1, 1.6 times 10 to the power negative 19, right? We can just say squared. Okay, since we have two electrons here. So therefore, O over, what is the distance separating the electrons? The distance is 3.2 times 10 to the power negative 12, right? So therefore we have 3.12 times 10 to the power negative 12, right? Times what? Okay, the distance is squared since it's R squared, okay, which means distance squared, times 4 pi times 4 pi times E naught, right? E naught, we've been given this constant, which is 8.85 times 10 to the power negative 12, right? So therefore we have 8.85 times 10 to the power negative 12, right? So therefore we are at this point now, right, to calculate the force between the electrons, right? So at this point we can just punch all of this into the calculator, and the calculator will spit out an answer, right? But since most students, okay, so we are going to punch all this quantity into the calculator, then it will spit out an answer, but we have to punch them correctly so that we get a correct answer, right? So therefore, firstly, we're starting with 1.6 times 10 to the power negative 19 squared, right? So therefore, we're going to the calculator now, right? So therefore, the bracket, we open a bracket, right, and say 1.6. So I want you to use this exponential button. This will help you minimize errors. So this exponential button means 10 to the power, right? So we have 1.6, right, times 10 to the power negative 19, right? So it's 1.6 exponential negative 19, right? Then we close the bracket, then we click squared, right? All this over, right? Then we need our over line, right? our division line over, right, over 3/3.2 times 10 to the power negative 12, right? So we're going to write 3.2 exponential negative 12, right? 3.2 exponential negative 12 just means 3.2 times 10 to the power negative 12, right? I've told you that the exponential button is standing for 10 to the power, right? So times what? Times 4 pi, right? Times 4 times pi, then times 8.85 times 10 to the power negative 12 again, right? Then we're saying times 8.85 exponential negative 12, right? Then we're done. Then we say equals, then the calculator spit out an answer, right? So this is the answer. So our answer now is 7.19, correcting to the nearest three significant figures, right? So 7.19 exponential negative 17. So this means the force was equal to 7.19 exponential negative 17, which means times 10 to the power negative 17 newtons. So that was the force between these two electrons. Then you're done.